Hello and welcome to Computer Tech and More. Today we're going to be taking a look at the UniFan SL-INF140. UniFan Infinity 140mm class fan. Let's get right into the graphs and the data. First up in the graphs is the case simulation test. The case simulation test can be looked at in a couple key different ways, and first and foremost, the most important for you, the viewer, is what size case you actually plan on buying. I took it at 4 key measurement points, which are very representative of standard case sizes. Now, this is specific toward more specific towards air coolers, where you'd have the heatsink. So these measurement locations are the distance from the front fan to the rough position of the CPU socket within the case. So the 6-inch mark is representative of a small form factor case. Something that is, again, a front-to-back airflow design with an air cooler, not the ultra-compact ones like the fractal design or fractal Terra type case, where they suck in air from the sides and then blow it out the top, or effectively a similar type design. Again, front-to-back airflow design. The 6-inch mark is also representative of a short throw distance. So, like getting your computer case, putting fans on the bottom of your case and blowing it up towards your GPU, that would be another example of that short throw distance. The 9-inch mark is representative of your compact towers. Something that could probably still hold an ATX or an MATX motherboard, and the GPU would be about the same length as the motherboard. Again, that front-to-back airflow design. And I envision it as like a Dell Optiplex. And then we have the 11-inch mark. The 11-inch mark is representative of your standard mid-tower cases. Something like the Corsair Stormtrooper looking case. I think it was part of the 500 series. So like the Corsair 550D would also fit into that category. Meshify 2C, something like that would be the 11-inch mark. Then the 14.5-inch mark is your bigger towers or longer towers. So think something that can hold a 100 or a 420 class radiator along the top. That would be a fairly long case, so the 14.5-inch mark would be representative of that. I'm just trying to use something so that you can imagine it. Again, this is specific towards air coolers. Now, why is this important, like scientifically? Well, the most perfect designed fan in the world would have a perfectly flat line. It would have no aerodynamic losses from the front of the case to the back of the case. But there are aerodynamic losses, so you want it to be as linear as possible and as gradual as possible. So kind of like case and point. Old style static pressure fans tend to spew air off to the side. In my opinion, you'll always want to select a fan that has a good concentrated airflow, but I understand that that is unrealistic. And depending on the case, the circumstance that you would like to use the fan, it may not matter. So for example, if you're hooking it up to a radiator or heatsink, AIO, something along those lines, or even at the back of your case for exhaust, the airflow doesn't necessarily matter as much, because if it's through a heatsink or radiator, the heatsink radiator will naturally straighten out the airflow going through it, and the air tends to expand through the fin stack anyways, simply because it is a pressure scenario and the air tries to fill in all the gaps. But, and as an exhaust, well, the air is coming out of the case, so it just kind of needs to get there. So it doesn't matter quite as much in that type of circumstance. But if you're using it at the front of your case for a good air cooler, you do want a good concentrated airflow so that the air can get to your CPU cooler. So a little bit of explanation of how a fan works. It accelerates the air through it. It pulls a small vacuum in front. So you do want a good high quality fan to supply this fan with air so it fills in this vacuum as efficiently and effectively as possible, improving the overall efficiency of the CPU air cooler fan overall. And this will drop your CPU temperatures or potentially noise levels by a little bit. I plan on doing testing on this in the future. I just haven't gone around to doing it. If you got interest in other types of tests, please let me know. So if you're using these fans on a radiator that is at the front of your case, you still want to make sure you got good strong airflow, especially if your GPU is air cooled. So if everything is water cooled, it doesn't matter as much. Like, you still want good fans, but the airflow pattern of the fan doesn't necessarily matter as much, so you can just go with whatever meets your performance criteria needs. But if your GPU is air-cooled, you want to make sure that there's strong airflow getting to your GPU, so you do want to make sure that there are high-quality fans to supply that fan with substantial airflow. Again, this is in the circumstance that you've got the AIO or a radiator at the front of your case. And if you're using these fans in a pull configuration on that front radiator AIO type scenario, it's even more important because the airflow pattern coming out of the fan will be identical to what we see in this sort of testing. While if you're using in a push configuration, the radiator will actually straighten out the airflow. So then you just want to make sure that it supplies enough air. So high enough air speed going through it. So you still want a high quality fan, but the airflow pattern doesn't matter as much in that circumstance, if that makes sense. If you have a question about it, I'd be happy to answer. Just leave it in the comment section down below. I'd be happy to re-explain it in a way that's more understandable. So then we got the two fans for this comparison sake. We got the SL-INF140 and we got the SL V2. I'm going to have a specific video on the SL-140 V2, but I figured that they should be compared directly in this video because they are both part of the Infinity line. They're both SLs and fairly similar overall, and we can see the general shape and airspeed dynamics of these two fans. But it's easier to compare it against some known quantity. So I have what's called my control fan. It is 3 parts A12X25 and 2 1-part A14, both Noctua fans, both very good in their respective categories. By combining these two fans, I hope to create a great composite fan, effectively a 130mm class fan, because 120s tend to do better at the 6 and 9 inch mark, while larger 140s tend to do better at the 11 and 14.5 inch mark, where larger diameter fans tend to fill a volume of air, fill the case volume with air more effectively than the smaller size fans. Mind, there is a limit to it, and it depends on the restrictions on the front of the case, where larger 200mm class fans often have like the brackets in the way, so you do need to be careful with regard to that statement. I'm talking where there aren't really any restrictions for the air to travel to the case. So with all of that said, this composite control fan is there to be like a general baseline mark for fans that are over it are considered good to very good. Fans that are basically at the line would be considered good. Just under it could be considered good to okay. And if they're way too low, then they'd be considered very, very poor performers. In this case, airflow type test. And so what are we seeing? Well, we got the UniFan SL-140 version 2. We got the original SL-140, and we got the SL Infinity. The colors are over here. So the Infinity is this blue line. And it is underperforming my control fan, but what we do see is that all of the SL-140s, I'm going to just lump them as together, are performing relatively similar compared to each other. Looking at things at 100% PWM fan signaling, we got the fan name, we got the RPM, and we got the decibel reading that I measured while doing the test. And my control fan also now has an RPM and a effective noise level. This is calculated based on the average or the combined results of the two fans that were used to generate that control fan. So the SL-140 and the SL Infinity are lining up very closely with the original SL. At the 14.5 chart, lining up fairly closely with my control fan, while the SL-V2 is kind of underperforming. How do they compare against other fans? Well, this is primarily 140mm class fans. However, there's a couple 120mm in there, like the A12X25, which starts off very high performer and then quickly drops off compared to other fans around it, but it's still outperforming many other 140mm class fans. So we have this red line is the SL-140 original. This green line is the SL Infinity, and the aqua teal color line is the SL-140 version 2. So all of them are kind of towards the bottom of the graphs. They'd be sufficient for case airflow, but it isn't what they specialize at. At 100% PWM fan signaling, we once again see them. They have changed some colors. And the Infinity here for this review is this green line, and it is well towards the bottom of the graph. So once again, well, you shouldn't be running your case fans at 100% PWM fan signaling because it indicates that something's gone terribly wrong within the cooling system of your computer, but it is towards the bottom of the graphs, and so thus it really shouldn't be a case airflow type fan. Things at noise versus airspeed. So this was taken at the 9-inch mark. The 9-inch mark was chosen because many fans, for consistency's sake, in this test, 120s and 140s can be directly compared against each other because they're all in the same testing apparatus. So I needed an airspeed over 0.5 meters per second, and the 9-inch mark gave me the most reliable results. While the 11 and 14.5 chart mark, I had too many fans that tended to drop below that 0.5 meter per second speed. That is the accuracy of my anemometer, or consistency of my anemometer. So I needed that data point. You can calculate at any of the data points. It just will adjust the results. Taking out the 6-inch mark, all the fans would look too similar to each other, meaning the good concentrated airflows and the non-concentrated airflows will look very similar results. So the 9-inch mark was chosen to get a wider separation between those two types of fans. So the infinity right here in this yellowish line is towards the bottom of the graphs. No surprise, we've been talking about that this whole time. And the SL-140 V2 is in a very similar type position. So they're not really case airflow fans, once again reiterating that same point.
Case airflow testing would be done at each of the different markers for a given amount of time for the blade to reach steady state with the fan at the end. LianLi UniFan SL-INF140.
Now we're on, to the CPU air cooler test. This is blown through my Noctua U12A cooler, and yes, I'm aware that that is a 120 millimeter class cooler. However, I still measure the anemometer directly behind the fin stack, so that is the airspeed that I'm reading, and it's done for consistency's sake for all the testing processes, so that 120s and 140s can be compared directly against each other. On the left side, we have RPM versus airspeed. Airspeed is vertical, RPM is horizontal. And this could be considered functionally a blade efficiency graph. It is how good is this blade design at shoving air through my CPU air cooler. The red line is once again my control fan, 3 parts AX A12 and 25 to 1 part A14. So we do see that the blade design for the SLs are a little bit better than my control fan, with the purple line, or purple dots, being the infinity one that we are specifically looking at in this graph. But all of the SL series tends to line up fairly closely with each other. Now, on the right side here, we have noise versus airspeed. Airspeed is vertical, noise is horizontal. Every 10 decibels is a doubling in noise volume. So even if these lines look linear, they are not. The relative noise performance does double every 10 decibels. I want to reiterate that over and over again. So the infinity here is actually doing really quite good. It is top of what we see on this graph. So I would put it in a good type category. The version 2 is a little bit over my control line, putting it in a good category, not quite very good, I guess. I guess the infinity I put into the very good. Anyways, let's see how they compare against other fans. So again, primarily 140 millimeter class fans. So now how does it compare against other fans within the 140 millimeter class category? First, a little bit of a note. This over here on the side here is a wattage versus airspeed. I did a number of tests on my CPU air cooler to equate what wattage equated to what airspeed traveling through it, letting the CPU hit thermal max, so steady state wattage, and then I slowly decreased the PWM fan signal down to its minimum level to get a wattage versus airspeed. This is an estimation, and I've calculated it to be accurate within plus or minus 5 watts. And at higher wattages, so there are a bunch of limiting factors within CPUs. As you increase wattage, clock speed is not a linear improvement. So at higher wattages, you get less and less improvement for your clock speed as the wattage increases. In a similar way, airspeed traveling through your cooler does the same thing. At higher and higher air speeds, you're getting less and less heat extraction from it at some point. So there's a curve to it. So at some point you're pushing air past it so quickly that it's not able to really pick up much more heat. So you've got the two main limiting factors both working against being able to achieve higher and higher clock speeds. So it's up to you to determine what is enough. So as a general note, the original fans that come on this cooler, the A12X25, you don't get that much extra performance bumping up to like a 3000 RPM fan, or even two 3000 RPM fans on that particular cooler. I was only able to get like 10 more watts of cooling out of it for another 700 RPM over the A12X25. So I can't make that decision for you. I'm only here to present the data. So again, my cooler was the Noctua U12A. My CPU is the i7-11700K. So if you don't have those two things, how can you use this data? Well, it's really simple. You can use it as a comparison standpoint. So this would be, let's say you have the Lightwings 140HS. It's moving in my cooler 0.6 meters per second of air. Well, upgrading to the Infinity allows it to push substantially more air. On my cooler, it's 1.4 meters per second of air. But what does that mean for you with different hardware? Well, it means that there's going to be an improvement in performance by jumping up to these higher fans, pretty much no matter what kind of cooling system you have. Now, how much improvement, I can't say for certain because I haven't tested enough different radiators, heatsinks, and everything like that to know like average improvements. But it does mean that you'd be able to, if you upgrade to these higher performance fans from one of these lower ones, you're going to be able to run your system at a higher wattage for the same noise level, or you're going to be able to run your locked system, so non-K series, non-X series, or limited clock speed, cooler for the same noise level, or you could back off the PWM fan signal and run your system at the same original wattage, but out at a lower noise level. So it allows you a direct comparison between how these fans rank in order. At 100% PWM fan assembly, how do they take a look? Well, the Infinity is sitting smack dab in the middle, actually performing really quite well overall. It does outperform the original A14, which is a great result, even if it is by 0.8 meters per second. But 0.8 meters per second on my particular cooler, so 0.1 meter per second, grants you probably about 10 watts of extra power draw that the CPU can take. So it may be worth it to you to have that sort of upgrade. And of course, we have the 3000 RPM fans right up at the top. And we have the noise levels listed so that you can decide what noise level is most important to you. So the Infinity 140 is actually pretty quiet considering the amount of air that it pushes.
I counted 8 RGB LEDs on the central ring of the fan hub. So 8 is a much better number than more value-oriented RGB fans, which usually appear to have 6. 8 allows for better color mixing, and I'm going to go ahead and make it do rainbow colors. There we are. So it has a better, smoother transitions than most other fans that have only 6 LED RGBs, and that's because you can have more light sources so that you can have that more in-between color between the two, so that there's just more opportunity to blend the colors together, which I do prefer, but if it's worth the extra cost, that is up to you to decide, and I can't make that decision for you. As for the frame itself, it does have a nice diffusers in here. I can't actually count how many RGB LEDs are in there. It's just too hard to really tell. That's just how good the diffuser is. And of course, the piece de resistance for this fan is the Infinity mirror, which on camera does not do it justice, but it truly looks fantastic. I'm going to put it back onto a solid color, and it just absolutely is the most stunning thing ever in a fan. Truly, LianLi like went over the top with this one, with that design. Unfortunately, the fan blade just doesn't keep up with all the aesthetics. So even the back of the fan looks fantastic. The central ring, the metal hub, basically the light diffusers around the edge. So even though it does have these posts there, it still looks pretty good from the back, but definitely better from the front.
Well, the SL-140s tend to be towards the bottom of the graph. Kind of unimpressive. Oh, I didn't... The RPM is cut off. I'm sorry. Now, how does it do airspeed versus decibel rating? Well, this orange line is the Infinity. And we see in here these jumps. These are like efficiency. So there may also be, it may also be nearing a harmonic, which is why you'd see this jump. It's hard to know for certain because I only tested every 10 PWM fan signal. If I guess I might as well talk about it now. So this is where I'm limited with this channel. So what I envision for the future is I want a better dedicated microphone for noise testing. That's like $200. I want a more accurate anemometer, something that is accurate within 0.01 meter per second as opposed to 0.1 meter per second. Because as you can see from these graphs, many of these fans look like they're functionally equivalent, and I'd like a finer granularity so I can definitively, like much more accurately, definitively say, hey, this fan is better than this fan, rather than saying they're functionally equivalent, even though it may not technically matter as much. I'm an aerospace engineer, so I like this technical side of things. I do run these fans through 3 passes in noise testing and in airspeed testing and average the results. So I can say for certain that they are in this order, but I would just like that finer granularity. Of course, that costs extra. I want to build a little noise isolating chamber. So nothing like Gamers Nexus or Linus Tech Tips. You know, I want to build just a small little chamber to absorb sound around while I do this fan testing. And I'm hoping that I can get it so I drop at least 5 to 10 decibels and smooth out the sound entering it so that I can give you the better data. I want to build a little test system. All in all, honestly, $2,000 would pretty much make me golden. I'm not asking you for money. But if you want to join me on Patreon, it will help. It will go directly into that. And I'll upgrade my whole testing if I ever get there. Otherwise, I'll keep doing testing the way I am doing it currently. And if you want to see that finer granularity, every, let's say, 5 PWM fan signal, as opposed to every 10, do leave that in the comment section down below. It will involve more testing, more time, but that would be something that I can implement into current testing methodology, but would be most beneficial to the long-term goal of what I see with this channel. All right, so back to what we're seeing. So there may be a little bit of harmonic in here, but I can't say for certain. But there is definitely at least an efficiency. So it jumps in performance, which means that the blades may become more efficient at this RPM. So that's 10 or 20, 30, 40, 50, 60, 70% PWM fan signal, and that's 80, and then 90% you see another jump, and then it continues to climb. So it's definitely right up towards the top. So indicating that the SL-INF140 is a fairly effective blade design at pushing air through a cooler. And you do see the SL-140 version 2 in here and the original SL-140 also in there. Also all ranked fairly well. The other fans listed are all what I currently am considering to be fairly good 140mm class fans, since they tended to be ranked relatively high, while also giving you a couple lower, not bottom ranked, but lower ranked 140s for the category comparison's sake. We have CFM testing. CFM testing is probably my least favorite test, as how many other channels use the CFM test. So CFM testing by itself is you have a fan, you have a tube. You blow air down the tube. So the fan is the same size as the tube. CFM is just cubic feet per minute. It's a volumetric flow rate. You can have it as a volume, or you can just measure the air speed. It doesn't much matter in my opinion, because they're effectively the same sort of thing. So the fan is blowing air down the tube. If the fan is the same size as the tube, there's no room for the air to expand if the fan has a tendency to blow air off to the sides. So that means all the air travels down the tube. But the problem is, if the air is trying to go sideways, it is now reflecting off the sides of the walls, creating an area of slower moving air in a larger boundary layer along the walls. This has a tendency to slow down the air, but not at the same rate that the case simulation test indicates. So if you do a CFM test like this, and all the fans will most likely be in this correct order, meaning high performance to low performance that we see in my case simulation test, but the difference between top performer and bottom performer is going to be dramatically different than what you see in the case simulation test, depending on what distance you actually care about. Because effectively, this is like taking the airspeed at more or less a point blank from the fan. So the case simulation test, I think, is actually golden, and it's the way that everybody should be doing case testing. The only exception would actually be hwcooling.net, which I actually really like their cone-shaped testing, and I would like to implement that in the future. Of course, I need to acquire a cone-shaped CFM testing apparatus. And I would want it sized to fit a 180 millimeter class fan so that there's plenty of room for those larger fans to expand air if they have a tendency to do that. So back to the graphs. So this is very similar to the heat-sink testing. Better fans top left, worse fans bottom right. And we got the blade efficiency graph. They all pretty much line up very closely with one another. Here, the control fan is just straight up the A14. It's different than the other tests with the control fan. The control fan is the A14. On this test for 140s, on 120s, it is just the A12X25. And the reason for that is 120s and 140s use a different testing apparatus here. So they cannot be directly compared against each other in the CFM test. And we do see that they line up fairly closely with each other. However, the SL-140 V2 and the Infinity are a little bit underneath the control fan here. So indicating that they're not quite as effective in that straight pipe type airflow as they were blowing air through the heatsink. In terms of noise testing, the Infinity is sitting right in line and a little over at higher RPMs. My control fan, which is definitely a great result overall, but the control fan does achieve higher RPMs and higher air speeds when we're taking a look at it as combining the A14 and A14 PPC versions. The other ones are sitting right in line with each other, so overall a pretty good result with the other fans. So how do they compare against the other fans in the category? Well, the Infinity is ranked really well towards the top in noise normalized testing. It is just barely behind the A14 PPC 3000, and the non-PPC is sitting down here. So that just shows some consistency between PPC version and non-PPC version. I don't know why. I've tested a few times, but this is just what I end up finding. The SL-140s are a bit lower in performance, but not that far off for the V2. So they're definitely all fairly good in this type of test. At 100% PWM fan signaling, sorry for this roundup. I could not get it to shrink in size in Excel, so that's just what it ended up with. But this is the RPM. The V2 is at the bottom of the graphs. The Infinity is sitting right here, and there is the SL. So that is just where they've ended up. And once again, we have the RPM and the noise level. And now we're on to CFM versus decibel rating in a graph form. The Infinity is sitting right here in the green line. It sort of starts off pretty good, sort of middle of the upper good fans, climbs. And so overall, it's doing actually really quite well. It just doesn't have the same sort of top-end airspeed, which is why it doesn't rank as well at 100%. And we see it ranking really well in noise normalized values. So if it had a little bit more grunt to its motor to achieve higher RPMs, it could potentially be ranked even higher. Unfortunately, this is where LianLi decided to limit the fan. Alright, now we're on to value proposition. The SL-INF140 is a $46 fan, as I could find standard retail pricing on Amazon. So that is where all of these fans, how the value proposition is calculated, based on standard retail pricing that I could find on Amazon. Note that depending on where you live and pricing, you may need to readjust this value proposition. And that's why I've presented all the data the way I have, so that you can easily recalculate if necessary. So if you're on an ultra tight budget, I do recommend that you pick a top value pick, because that's how you get the best bang for the buck for your particular system. If, however, you got a little bit of extra spending money, so you want an extra, and by an extra, I mean better noise performance and better maximum performance, you would use the earlier graphs in the data. If you want a little bit better RGB, that would be another extra, or a certain other aesthetic, that is your other extra, and that is up to you to determine. If you've got unlimited budget, well then buy whichever fan you like, because you got that unlimited budget. So what is value proposition? Value proposition is a relative performance per dollar. What it isn't is maximum performance. This isn't how good this fan actually is. It is simply a indication of how good it is for a currency, per dollar. So you need to decide what what is most important to you. So it's pretty clear that the UniFans are not a good value. So I'm gonna just go through it relatively quickly. 11-inch mark, they're once again not really a good value. They're ranked pretty close to the bottom. They're just too expensive for how relatively little performance they have. So once again, CPU air cooler testing here. The SL-INF140 V2 is at least just about average, a little bit under, but close. So with these fans, you're literally paying a huge amount of that extra for that RGB. So again, I'm just talking, presenting the data. So in this, you're paying, it's like 90% extra, 10% for the performance that you're getting out of it. While most other fans, you're paying more for the performance characteristics that you want out of it, and then a small percentage for the extra. So I can't make the decision for you. Once again, it is up to you to decide what is most important. So while we're here, just a little wrap up with my thoughts on it. So LianLi has made itself as sort of this luxury fan brand, where their fans are incredibly pretty. I particularly like the RGB on the Infinity series, but unless I went full liquid cooling, personally, I wouldn't devote the expense to buying them. That's just my thought. They just don't have enough performance to justify the expense. So you're welcome to do whatever you want. It's just my opinion on the matter. They are very pretty, but they don't have the performance that matches their prettiness. What I'd like to add in the future is also, I almost forgot about this, is longevity testing. It is something that I currently don't have the capability to do. That would be part of that. Help me out on Patreon and make this channel grow a little bit, where I'd be able to do longevity testing. I'd have all of these fans just running until they fail. And I'd have a little timer, measuring how long they're going for, so that we can, determine how long these fans actually last. And this would also include the RGB, because I'd have the RGB running nonstop as well to see how quickly those lights burn out. So that is just my thought, and now let's move on to the next section. All right, and at the end of every video, I do like to show off my raw data. This raw data does belong to me. I'm the one who generated it. It takes me about 1.5 to 2 hours to generate this level of detail. As I would implement more tests, would take longer to do more testing. But if you want to use this data for your own personal use, i.e. putting it into your own Excel so that you can calculate value proposition, make your own graphs, whatever you want, you're more than welcome to do so. I just ask that if you're going to use it in any sort of video, publication, written, journal, video, whatever, anything like that goes out into the public space, you do reference me and my channel. After all, I am the one who worked hard for this data. If you've got suggestions on how I can improve my videos to make them more pleasant to watch, easier to watch, whatever along those lines, please leave it in the comment section down below. I do read through it and I do answer questions and stuff like that. I am looking for constructive criticism here. Just note that it may take a little bit of time for me to implement, because I tend to buy a lot of fans and then record a lot of videos, and then over time I then edit and filter it together. So it just may take a little bit of time for me to implement changes into the videos. But note that it would be coming if I can easily implement those changes. If you got suggestions for fans for me to take a look at in the future, please leave that in the comment section down below. I certainly am always looking for more fans. For ease of my purchasing, I do ask that it be available on Amazon. That is the easiest way for me to acquire fans right now. Newegg would also be acceptable. But other than that, I have a Patreon page. Every little bit that you can help there would go directly into the future of this fan testing. So if you like what I'm doing, I do ask that you show your support there. Just buying fans has been a huge endeavor for me. But like I said earlier, I'm an aerospace engineer and I have a background in computational fluid dynamics. So this is a specialty of mine, and I'd like to think that I'm a trusted expert, or at least a close to trusted expert on the topic. Subscribe for more content. It'll help with the YouTube analytics. And I hope to see you next time here on Computer Tech and More. Have a